The second use case that we'll discuss today is saving lives using AI. Now, this is very interesting. This is a very recent project that we did with the World Mosquito Program, which is an NGO, and their aim is to help prevent disease like dengue, chikungunya, yellow fever around the globe. Yeah, so this is the slide. Yeah, so like I said, mosquitoes are the most deadly animals on the planet right now, and they spread a lot of diseases, one of which is dengue, and it's endemic in 100 plus countries now. So WMP, World Mosquito Program, is an NGO which is working to fight dengue and few other diseases caused by mosquitoes. They found a very innovative technique. So they inject a Wolbachia, which is a naturally occurring bacteria, which occurs in almost 60% of the insects, but unfortunately not in mosquitoes. So they inject these mosquitoes with Wolbachia, and when a Wolbachia infected mosquito mates with another mosquito, the other mosquito will also get Wolbachia. Now, what happens is once the other mosquito has Wolbachia, all its offspring will also have Wolbachia. So it is an exponential process. Once they start releasing mosquitoes infected by Wolbachia, eventually the entire population, mosquito population in a locality will get infected by it. And if a mosquito has Wolbachia, they don't have the ability to carry dengue or chikungunya or yellow fever anymore. So they can transmit these viruses, and it helps prevent transmission of these diseases. They have done pilot testing in multiple sites. Here is an example in Queensland, where they release these mosquitoes in the form of small packets, either in the form of adult mosquitoes or in the form of eggs. And if you look at the graph at the bottom in terms of number of dengue cases, you can see it slowly decreasing. And after, let's say, 6 to 8 months of the release, they don't release at once. They release it at a weekly or a bi-weekly interval. So after 6 and 8 months of release, almost the entire mosquito population in a locality gets infected, and they then can transmit the disease, and the number of cases of dengue fall almost zero. Okay, they have tested it in multiple sites. Most of them are pilot sites, but the vision that they are targeting is 100 million people by 2025. They want to save 100 million lives before 2025, and that's where they need AI. Okay, now how does AI come in here? So breeding mosquitoes with Wolbachia is a very costly process. Releasing mosquitoes in human settlements is also a costly process. To optimize the release plan, you need to know where humans are, because as it turns out, the particular mosquito, Aedes aegypti, is attracted to humans. They only bite humans, they don't bite any other animal. And their population is directly proportional to human population. But like I said, in most of the developing and underdeveloped world, we don't have human population available at enough spatial as well as temporal resolution. Okay, so that's what we wanted to work with. If we could get an accurate estimate of how humans are located in a geography, it will then help WMP to design a better release plan. So the solution that we designed is you pick a city, and we are not just picking any city. We picked around 10 cities for WMP, and then we built a deep learning model, which, given a satellite imagery, extracts the building footprints of the place and then takes population data either in the form of sensors or, for example, graded population of the world or world view, which is available at a lower resolution, which is at a kilometer resolution, and then based on building footprints, estimate what the human population looks like at a 100 meter cross 100 meter grid. So if you see the image on the left, the satellite image, and the image on the right, you can see the distribution of the population, right? So the bluer or greener it is, the higher the population there, and the red color, orange color indicates a lower human population. Now, how does it work? So if you look at a city level, this is how the population looks like, and if you look at a much higher resolution, this is how it looks like. Now WMP knows exactly how human population is distributed for the entire place, and based on that they can then design their release plan. If they want to release it weekly, bi-weekly, how many mosquitoes they want to release, or what period of time they want to release, and this saves them a ton of cost.